So this is heat loss calculation through bare and log pipe under the Mechanical Engineering Laboratory 2. Ang title is heat loss calculation, hindi testing. Okay? So, pero sa testing, siyempre, ito rin ang principle na gamitin mo yung mga formula. So, nakita nyo sa figure, ito yung composite pipe, may mga tatlong insulation, tapos and tatlong layer. Ito yung thickness ng pipe, insulation, and either cladding or other insulation. So, ito yung equivalent electrical diagram. Discuss natin yan. So, meron kang heat transfer, di ba? So, heat loss from log pipe. Ibig sabihin ng log pipe, may insulated. Yan, may insulation siya. Heat loss in gain takes place from a pipe carrying hotter or colder fluid than ambient temperature. If ambient is less than the surface temperature ng pipe, that is heat loss. If the ambient is hotter, so heat gain. Insulation reduces the heat loss to the surrounding if the heat loss is considered. Heat loss depends upon the number of factors like insulation thickness, ambient temperature, and wind speed, etc. Wind speed kasi yung effect niya sa surface. Overall heat transfer coefficient of an insulated pipe is defined as U is equal to 1 over D sub 3, refer to the figure, over D1 H sub n plus D3 ln of D2 over D1 over 2K of 5 plus D3 ln of D3 over D2 over 2 over K insulation of pipe, insulation, plus 1 over S of air. So insulation yun na. Where K pipe, K insulation are thermal conductivities of pipe and insulation. Its N is the heat transfer coefficient for fluid flowing inside the pipe. In H air is the heat transfer coefficient due to air flowing outside the pipe. So the first two terms of the denominator in above equation are generally smaller compared to remaining two terms and can be neglected. For this example, first term due to pipe fluid is ignored. Okay? So wait, ayusin lang natin to. Okay, so this is H of air. So itong first term is usually neglected. Isa lang steam, mga water. Madalas mababa yung itong term na to. So ang air mataas. Okay? Kasi mababa lang yung H of air lagi. Sa gas. Okay, air side heat transfer coefficient H of air. Ito yung formula. Air side heat transfer coefficient is due to combined effect of convection and radiation. Assume a temperature at cladding surface, T surface, and steel pipe, T interface. Calculate average air film temperature as follows. Pipe surface, may cladding ka. So, estimate the thermodynamic properties of air like thermal conductivity, K, viscosity, mu, expansion coefficient, beta, then 1 over T, is equal to 1 over T average. Air density, rho, kinematic viscosity, specific heat, Cp, and thermal diffusivity, alpha, at average air film temperature. These properties are available in literature in form of tables. In literature sa mga other books. So, yan. Nayos ko lang. Oh. So, its radiation. So, the heat transfer coefficient due to radiation is calculated using the following relation. So, where rho is equal to constant, Boltzmann constant is 0.1713 times 10 point negative 8 BTU per hour square foot plus Rankine exponent 4 is 5.67 times 10 exponent 8 watts per meter squared Kelvin exponent 4. So, NE is the emissivity of for cladded surface. S radiation is sigma E times T exponent 4 ng surface minus T exponent 4 ng ambient divided by T exponent surface minus T exponent ambient. This capital T is for absolute temperature. So this is absolute. Yan. Okay. Kinukuha natin to kasi dito to sa air side coefficient. Combined effect of convection and radiation. So, based on that, yan, mga coefficient. So, next is the radiation. Next is the convection. Dito na yung papasok yung mga properties mo. So, convective heat transfer coefficient comprises of force and free convection. Force convection can be modeled based on correlation by one of the equation given by McAdams. Yung heat transmission by McAdams. At marami doon ganitong mga correlation. HDO over Q sub F is equal to 0.24 times D sub of B rho over mu F exponent 0.6. The value D sub of B rho over mu sub F, which is the Reynolds number, should be between 1,000 to 50,000. So yan ang limit niya. D sub O is the outside diameter. And K sub F and mu sub F are evaluated at the film temperature. Film temperature, yung temperature ng surface. Malapit doon. Hindi. Average. Film temperature. Iba yung surface temperature. Okay? So, pre-convection is calculated for hot surface in atmospheric air. Ibig sabihin, yung Reynolds number mo is less than dito sa boundary. Okay? Or, di ba yung laminar flow? O less than dito. O walang blower. So, basta walang blower, dito yung mag-depend ka sa speed. Kung masyadong mabilis, ibig sabihin nun, may blower siya. So, vertical phase over 1 foot high, S sub C is equal to 0.27 times delta T is 0.25 BTU per square foot, that's our loss of Fahrenheit. Horizontal pipes and vertical pipes over 1 foot high, S sub C is equal to 0.27 times delta T over D sub O, 0.25, so BTU per square foot, that's our the speed. Okay? This is for more than 1 foot. For less than ito. So, where the subscript C is used as a reminder that only convected heat is involved and that the radiant heat should also be considered. D sub O is the outside diameter in feet. Delta T is the temperature difference between the air and the surface. So, wala problema yung question mark. The air side heat transfer coefficient is calculated as following. H sub air is equal to S radiation plus H convection. Yan. So, meron ka ng H of air. Now, the overall heat transfer coefficient, U. So, thermal conductivity is yun yung sum nung denominator. The thermal conductivity for insulated material and pipe is available in literature and depends upon temperature. So, yan, first temperature ng pipe. Heat transfer resisted due to the pipe and insulation is calculated using the following relation. So, R ng pipe is D sub 3, ln of D2 over D1 over 2K pipe. Our insulation is equal to D3 ln of times ln of D3 over D2 divided by 2K of insulation. Then the overall heat transfer coefficient is calculated as R overall is equal to R pipe plus R insulation plus 1 over H of air. So neglected yung sa fluid. So U is equal to 1 over R overall. So ito yung overall heat transfer coefficient. So wala pa tong yung sabi nating Pauling factor. Heat blowing through insulation is estimated. Q is equal to T operating minus T ambient over R overall. So, okay, or U times delta T. Operating sa loob and the ambient. Kalabas. Then, a revised estimate for interface and surface temperature is made. So, interface, ito yung mga contact dyan. So, T interface equal to T operating minus QR of pipe. T surface equal to T interface minus QR insulation. Above step are repeated with this new estimate. Still, there is negligible difference in temperatures. So, trial and error na solusyon nyo. Diba? Makukuha nyo yung, bawa ito lang. Ito yung pipe. So, ito yung surface mo. So, kasi ina-average mo yung temperature. Initial trial mo is yung ambient saka ito. So, next time, kunin mo na itong interface. Kasi interface saka ambient, yan ka naman mag-average. Diba? Hanggang sa wala nang change. So, heat loss per unit length of pipe is estimated as by D3U. Sa diameter, kasi yun ang mamimissure mo. The heat loss per unit length of pipe. Now, for the, yun yung sa sa insulation. For the heat loss from bare pipe, all above steps are repeated with resistance due to insulation not considered. So, our pipe is dito, ln of dito over D3. So, kasi yung D3 mawawala, magiging dito kasi insulation mo D3 is equal to D2. So, divide by 2K pipe is R pipe plus 1 over XR. Okay? So, dito kasi, di ko panano kung na-consider. Halita. So, dito, hindi natin kinonsider yung fouling factor. Sa mga heat transfer nyo, consider yan. Okay? So, sa ibang topic na. Ito kasi presentation lang ito ng, ng calculation. Pwede mo lang i-include sa actual. Idagdag mo lang yung 1 over SF. Ito as new. So, testing ka yung bago. So, example number 1, a 3-inch steel pipe schedule 40 is carrying hot oil at 180 degrees and insulated with 50 mm thick magnesia insulation. Insulation is cladded with a sheet with surface emissivity of 0.9. Ambient temperature is 28 C and wind velocity is 3.5 meters per second. Calculate surface temperature and heat loss per unit length from insulated and bare surface. Okay? Surface temperature ng sa diameter, that's iba yun sa ambient, di ba? May mga hot surface, yun. Given 3N steel schedule 40. So, mga properties niya, tutingin na lang kayo sa table. Marami sa internet. Hot oil at 180 C. Insulation is 50 mm magnesia insulation. E is 0.9. Ambient temperature is 28 C. Wind velocity V is 3.5 meters per second. So, required. So, surface temperature and heat loss from insulated and bare pipe. Dalawa. So, solution for carbon steel pipe, PN schedule 40, ang ID is 3.068. Yun yung D1 mo. Sa diameter, ito yung pipe na yellow. So, 3.068 inch or 78 mm or 0.078 meters. Dito, out sa diameter ng pipe is this 3.5 inch is 0.89 mm or 0.089 meters. Okay, huwag yung inalagay na 89.09. Yan. DT is equal to OD plus 2 times 50 is equal to 89 plus 2 times 50 is 189 mm is 0.189 meters. Yun na ito yung sa insulation D3. From thermodynamics by first, thermal conductivity of pipe, steel, case pipe is 45 watts per meter Kelvin. Thermal conductivity of insulation, magnesite insulation, magnesite, magnesia. So, K insulation is 0.062 watts per meter. Okay, magnesia yan, magnesia. 0.062 watts per meter Kelvin. Hindi ko na-change kasi nasa docs, ganun din. Okay. Change ko rin kaya. Wait lang. For air, A insulated pipe lag. So, insulated. Wait lang. Okay, so ayan, magnesia insulation. Then R5, kunin natin yung mga resistant na. R5 is equal to D3 times ln of D2 over D1 divided by 2K pipe or 0.189 times ln of 0.089 over 0.078 divided by 2 divided by 45 is 0.000277. Yung insulation naman, R insulation is D3 times ln of D3 over D2 over 2K insulation. Substitute values, meron tayong 0.8189 times ln of 0.189 over 0.089 is 1 divided by 2 divided by 0.062 is 1.14 7886. So S of R, SDO over K sub F is equal to 0.24 times D sub of B rho over mu F 1.6. So velocity of air is 3.5 meters per second. Diba yun yung as first trial, assume TF, T operating plus T ambient divided by 2 is equal to TF is equal to 180 plus 28 over 2 is 104C. At 104C from thermodynamics by Peirce, 104C is 219 Fahrenheit. So mu sub F is equal to 1.45 times 10 negative 5 pound mass per foot per second. Convert this to SI units, magiging 1.45 times 10 negative 5 pound mass per foot per second times 1 kilogram over 2.205 pound mass times 3.281 feet per meter is equal to 2.156 times 10 is point negative 5 kilogram meter second. Next, Q sub F of air at 104C or 19 Fahrenheit. Q sub F is equal to 0.218 times 0.14419 is 0.03143 watts per meter squared Kelvin. Yung kasing sa 219 Fahrenheit is English yung makukuha mo sa table which is 0.218. Then this is a convection factor para maging watts per meter squared Kelvin. Yeah. Kaya yan yun. Rho at 104C, pressure is 101.325 kilopascal. So rho is equal to, this is air. Pwede mo gamitin P over RT, 101.325 over 0.287 divided by 30.2 plus 273 is equal to 1.1644 kilogram per cubic meter. Teka, bakit 30.22? So D sub O is equal to D sub 3 is 0.189. Right na. Okay, so to density at 104, pressure 101.325. So density is P over RT is equal to 101.325 over 0.287 over 104 plus 273. So 104 to is 0.965 kilogram per cubic meter. Then given is D sub O is equal to D sub 3 is 0.189 millimeter. And formula, H, substitute this sa formula yung ano, H is equal to 0.189 over 0.03143 is equal to 0.24 times 189 that's 3.5 times 0.9365 over 2.156 times 10 point negative 5 exponent 0.6. So H conduction is 18.888 watts per meter squared Kelvin. Also, H radiation is equal to sigma E times, times T exponent 4 surface minus T ambient exponent 4 over T surface minus T ambient. Substitute values becomes 5.67 times 10 exponent negative 8 times 0.9 times 180 plus 270 exponent 4 minus 28 plus 270 exponent 4 over 180 minus 28 is 11.382 watts per meter squared Kelvin. Ito yung sa radiation. And total niyan is H air is equal to H convection plus H radiation is 18.886 plus 11.382 or 30.268 watts per meter squared Kelvin. Then R overall, right? So the R overall is 1.1812. So Q is now operating minus temperature ambient divided by R overall is 180 minus 28 over 1.1812 is 128.683 watts per square meter. So the interface temperature is T operating minus QR. 5 is 180 minus 128.683 times 0.000277. R5 doon sa isang slide is 179.964 degrees C. So ito na yung interface temperature. Then sa surface temperature is T interface minus QR insulation. Diba sa labas ng pipe insulation. So T surface now is 179.964 minus 128.683 times 1.147886 is 32.3 C. So ito yung estimated na magiging temperature mo doon. So the average temperature is T surface plus T ambient divided by 2 is 32.3 plus 28 over 2 is equal to 30.72 C, which is very much less than 104 C. Yung na-assume natin. Na-assume natin doon. Okay? Kasi nga dahil sa insulation. So lalabas agad dito na bumaba siya. Pero hindi pa yun ang final. So next trial, use TF is 0.2, C is centigrade is 86 Fahrenheit. So ito na yung last trial ko. Okay? So another trial mo is siyempre 30.72. Then ulitin mo hanggang sa maging 30.2. So at 30.2 C from thermodynamics by first, 30.2 C is 86 Fahrenheit. New sub F is 1.25 times 10 exponent negative 5 pound mass per foot second. Convert that to SI. Okay. So mu sub F is 1.25 times 10 exponent negative 5 pound mass per foot second times 1 kilogram over 2.205 pound mass times 3.281 feet per 1 meter. Mu sub F is equal to 1.86 times 10 is negative 5 kilogram meter per second. Okay? Yung pag-convert ko isa-isa, hindi yung biglaan na pound. Yan, kung saan conversion yan, diretso na. Okay? Mas madali, maalala yung mga ganito. So kf of air at 40.2 C or 85 Fahrenheit is kf is equal to 0.1674 times 0.1441 and conversion factor is 0.02414 watts per meter squared Kelvin. Density at 30.2 C is rho is P over RT is equal to 101.325 divided by 0.287 divided by 30.2 plus 273 is 1.1644 kilogram per cubic meter. So also, D sub was equal to D sub 3 as 0.189 millimeter. Oops, meter to meter. Pause ulit tayo. So DO is equal to DT, 0.189 meter. So H times 0.189 over 0.02414 is 0.24 times 0.189 times 3.5 times 1.163 over 1.86 times 10 negative 5 is 0.6. So H conduction is 18.062 watts per meter squared Kelvin. So radiation naman, H is sigma A times T surface exponent 4 minus T ambient exponent 4 over T surface minus T ambient is 5.67 times 10 negative 8 times 0.9 times, then 32.3 plus 270 exponent 4 minus 28 plus 270 exponent 4 over 32.8 minus 28 is 5.687 watts per meter squared Kelvin. So H air is equal to the sum of convection and radiation is 18.062 plus 5.687 is 23.749 watts per meter squared Kelvin. So R overall is R5 plus R insulation plus 1 over H air is 0.000277 plus 1.147886 plus 1 over 23.749 is 1.1927. So now the Q is the temperature operating minus the ambient over R overall is 180 minus 28 over 1.19027 is 127.702 watts per meter squared. Then Q interface is equal to T operating minus QR. 180 minus 127.702 times 0.1000277 is 179.965 C. Kaya ito yung fluid temperature mo. Ito yung sa surface other side. Outside surface temperature or sa interface. So the surface, the interface pala ito. Then sa surface naman is T surface minus QR insulation, surface ng insulation to outside. So 179.965 minus 127.702 is 1.14886 is equal to 23.4 C. And take the average ng surface temperature and ambient temperatures divide by 2. 33.4 plus 20 divided by 2 is 30.7, approximately 30.2. So ito yung ginamit ng mga properties. So therefore, T surface is 33.4 answers. Lapit na yun, di ba? So isang trial pa, pwede pa. So the heat loss per unit length of pipe is estimated as follows. Heat loss is equal to pi D3Q. So pi times 0.189 times 127.702 is 75.85 watts per meter. This is your answer. Letter B, bare pipe, walang insulation. So, for air, HD over KF is equal to 0.24 times D sub of B, rho over mu sub F times 0.6. So, B is 3.5 meters per second. Again, as first trial, assume TF is the average. Ang average niya is 104C. So, dito, nakuha natin yan, 23.749 watts per meter squared. So, mali. This is different. Wait now. So, ito pa, 30.268 watts per meter squared Kelvin. Ito yung initial trial natin yan. Kasi 104 ang ginagamit natin. So, R over is equal to R5 plus 1 over HL. Walang insulation. So, 0.000277 plus 1 over 30.268 is 0.033315. So, Q is equal to T operating minus T ambient over R overall is 180 minus 28 over 0.033315 is 4562.5 watts per meter squared. So, the interface temperature is the operating minus QR is 180 minus 4562.5 times 0.000277 is 178.74 C. Yan ang interface. Then the average temperature is T surface plus T ambient is 178.74 plus 28 over 2 is 103.4 degrees C. So approximated na sa 104 or another trial. So the surface temperature is 178.74 C. Heat loss per unit length of pipe is estimated as follows. Heat loss is pi D2Q kasi wala ka ng Q3. Wala ka insulation. So pi times 0.089 times 4562.5 is 1275.9 watts per meter. So this is higher than with insulation. Okay? Yung answer nyo. Next. Heat loss from piping charge for piping intended to be installed outdoor. Outdoor to. So, may mga table yan. May indoor, may outdoor. So, ito yung outdoor. Insulation type, glass fiber, calcium silicate, cellulose gas, rigid cellular urethane, foam elastomer, mineral fiber blanket, expanded perlite. So, insulation factor is 1, 1.5, 1.6. Heat loss per inch thick based on K factor is 0.25, 0.375, 0.4, 0.165, 0.29. This is the heat loss per inch. So, ito naman yung insulation thickness, then pipe size. Andito yung ito yung tubing size, ito yung pipe size. Ito yung ito yung delta T ng ambient saka surface temperature. Ito yung heat loss na ng pipe. Okay? So, pag pipe ka ito, pag tube ito, pag pipe 1 inch, lalabas ka dito sa insulation thickness, 1 inch, yan ito. Lalabas yung mo, BTU per hour per square foot. So, ito yung daan. Pause ko muna. Okay, balikan ko lang. Itong insulation factor 1 based yun sa 0.25. 1.5 is 1.5 times 0.25, 0.275. So this thickness is the thickness of insulation then per inch. So ito BTU per hour Fahrenheit square foot per inch pa yan. Okay? Area. So 0.25 kung 2 inches, so times 2 mo yung heat loss, times mo na ang surface area, makuha mo yung BTU per hour, transport pa ng delta T. Okay. So yun. Bagal lang. So, andito na yung tabulated niya. Okay. Then sa pipe, sa standard na to, standard size and standard insulation. And this delta T. Okay. delta. So thank you very much.